Okay, so we're gonna solve number 1. But first of all, let's get rid of these because I don't want them. Bye-bye. Yes, okay. Now, the way to solve by completing the square. First of all, I recognize this is much easier to solve by factoring, so it might not be a good example for completing the square. But I promise you there are cases where equations like this where quadratic equations will be more easily solved by completing the square. And the way to do this is to write out this expression, moving this final term a little bit to the right, so that we have space for a little fake term we're going to insert here to complete the square. Remembering also to either balance out that fake term that we added on this side of the equation, or you could also put it back in on this side, and then eventually you resolve the equation. What do I mean by all of that nonsense? Well, let's write x squared minus 4x, and again we're going to move this guy a little bit to the right, so minus 60. It's still the same equation, but we've just warped it a little bit, and then we put a 0 there. And now our task is to complete the square. Complete the square. And I hope you remember what we did during our session. We had said that to complete the square, we're trying to generate some expression here that is a perfect square. And the way to do that is to take this this coefficient here, 4 or minus 4, it doesn't quite matter. Let's take minus 4. We're going to divide it by 2, and then square that. So minus 4 divided by 2 should give us minus 2. Minus 2 squared should give us 4. And then we reinsert that term 4. We reinsert that term 4 into the equation, plus 4. Making sure, of course, to balance out this plus 4 on this side of the equation. So we add in plus 4 here. Okay? So erase that. Okay, and now what I'm saying to you is that just by doing that, we have made this expression here a perfect square. A perfect square whose square root is x minus, we take this minus 4, we divide it by 2, minus 2 all squared. Okay, so the square root is x minus 2, so if we square it, we get back this expression. And then we can complete our equation. Minus 60, oops, sorry, let's not change color arbitrarily. Minus 60 is equal to 4. And the equation now becomes fairly easy to solve by rearranging and then taking the square root of both sides. But just in case you didn't understand what happened here, let's work through the expansion identity that I expect you to know. To understand this conversion, you need to understand the following expansion identity. A minus b all squared evaluates to a squared. So a minus b all squared, you know, is a minus b, and if you take a multiplied by these two and then take minus b multiplied by these two, you should get, let's get rid of that because it's cluttering up our screen, you should get a squared minus 2ab plus b squared. Okay? And I'm going to rewrite this expression just a little bit to make what we're trying to do here blindingly obvious. Well, I'll try to make it blindingly obvious. We'll see if it's actually blindingly obvious. You will be the judge of that. And what we're going to do is we're going to write b in blue. So B for blue, just to make what we're doing very clear. Write the B in blue, and then we're going to write this minus 2 here in pink. Let's write it in pink, because that's my favorite color. Okay, pink, minus 2 there in pink. Or we'll just write the 2 in pink. Okay, so now what I'm trying to show you is that this expression here, x squared minus 4x plus 4 is analogous. What do I mean by analogous? It basically looks like this one up top, a squared minus 2ba plus b squared. All right, so imagine for a second that we were trying to expand this out, and we just had a squared minus 2ba, and we were trying to figure out how to get this last expression. What we might do is take this term out here. Okay, we might take this term out here. Sorry, not that term. This term out here. Oh, I'm making a mistake again. This term indeed out here, minus 2b. We might take that term, minus 2b, divide it by 2, and that should give us what? That should give us minus b, and then square that. Minus b squared should give us what? B squared. And so that's how we get this final thing here, plus b squared. So a little algorithm to complete this square, this incomplete square, to complete it is we take this guy here, minus 2b, divide it by 2, and square it. And then we get this b squared. Okay? And so now we can add in our plus b squared over there. Over there. Okay? Now, notice in this expression we have below here, the x is really equivalent to this a. The x is equivalent to the a. And to make that clear, let's write it in green, in a darker green. Oh, it's quite hard to select colors on Photoshop, especially when you have a very cheap trackpad. So let's write that as x squared. Okay, and let's see if we can break up this second number, minus 4x, into something that looks a bit more like that. Okay, so what we're going to do is, we're going to take this x squared, put it down, okay, and then we'll take this minus 2 from here, take that minus 2 from there, and put it in this equation. And now we need to figure out what value can we put in parentheses here before the x, to make this look like that. Well, we just need to put a 2, right? You agree, just a 2. We put a 2, sorry about the color pick. Oh, la 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 la. Come on, give me the right color. If we put a 2 there, all right, then now this comes out to that. You agree? Okay, minus 2 times 2 is minus 4, and so that looks like that. All right. And then that same 2, we can then square it. So we can take that same 2 and square it to get our final expression. And now notice that x, let's make this final x green. Notice that x here is equivalent to a over there. Minus 2 is equivalent to minus 2, of course. B is really just 2, or minus 2, right, because we have here a negative outside, okay? And this b squared is again 2 squared. So you see that what we did here, by taking the minus 4, dividing it by 2, and then squaring that, was really the same thing as we did here, taking this minus 2b, dividing it by 2, and then squaring that to get there. Okay? I hope you see the concordance. I hope you see the similarity. If you don't see it, let's bring this guy a little bit closer. Let's bring that guy a little bit closer to that one. Even though the screen is now getting incredibly messy. It's an incredibly messy screen. I'll bring that a bit closer just so it's very obvious. Okay? Let's erase some of that junk. So I hope you can see now that this expression here is basically the same as that, which means we can go backwards the same way in this one. We can go backwards to a minus b squared. In this case, we can go backwards to x minus, the equivalent of b here is 2, right? The equivalent of b from here to there is 2, x minus 2 all squared. Okay, hopefully I've confused you more than I've made things make sense. If that's the case, then I will try to solve that when I come to you. Okay? So now we have x minus 2 squared is equal to, we can kick this guy over to that side of the equation, or we could add both sides, add 64 to both sides, as you please, as you want to say it. And then we can take the square root of both sides. This square root just cancels out the 2, and that square root, this square root cancels out the squared, I mean, and that square root should give you either, sorry, either plus or minus 8. You agree, right? Minus 8 squared is equal to 64, and plus 8 squared is equal to 64. Okay, so now, which means that x is either plus 8 plus 2, which is equal to plus 10, or minus 8 plus 2, which is equal to plus, sorry, minus 6. Okay, and so these are the two solutions to our equation. And if you like, you can go and plug them back into the original expression or equation to see if that does indeed hold. But I know that it holds because I've solved this before. And so, yes.